file system. And it's going to be a high-level talk about the file system concepts. I'm not going to do a low-level description of file system types like NFS, something like this. I'm not going to talk about that. So now when you sit with your terminal or your shell, maybe you think, how do I actually change the directory? How do I list my files when I don't have a GUI? I cannot click, I cannot get a graphical user interface that shows how it looks in my file tree. So that is what we are going to look at. How do we navigate it? How do we find files and directories? What are paths? And what are options and or flags, as they are often called, and arguments that you can give to shell commands. And you are going to try the tab completion. So this picture here, it shows the Linux file system directory structure. And I guess I could open on my own machine, because doing something like tree in the top root directory will give you a tree output of what is on the machine, but on a supercomputer there will be a huge number of files, especially because there are many users on it. But if you go up a couple levels here, I am now in the root structure of my tree. And here are some directories that are commonly there. The ones that you will almost always find is bin or /bin to say that it's at the root, because this slash here indicates the root of the tree. And this one will usually be there. It will contain some executables. The /home will contain home directories. And there will be things like /user and userlib and userlib64, userbin, which are specific directories for things that are user installed, or rather system-specific binaries and things like this will be in userbin. And I will try and run the command tree. Probably will go badly because it has AFS installed. And AFS is, well, it has a very huge tree structure. Let's just put it that way. So I think this was a mistake to do that. I'm going to break out of it and close it. Yes. And I'm going to open this instead here. I did this and waited for a long time until I did this. But if you do tree on your own machine, tree and -dx minus capital L1, then it only goes in one level. And then you avoid it traversing down it. But this is just to show everything that is under the root structure. These things are symbolic links. We'll talk about them later. So this is the structure that you will usually see. And under the root, if you go up until it says just a slash. And here is a list of them. Slash is the root. And this /user/bin or /whatever, when you go to some place on the tree, you call that a path or path name. It represents the location of a file or folder on a computer, file system or file tree. And this is a graphical representation of it. Here's the root. Under it, you have all these many other directories. And for instance, under user, there's bin and lib and other things. Under home are the home directories for all the users. Often user installed binaries go to opt or optional. But this is an important character, the slash. It represents the root directory, and in that case, it sits at the front of a file or directory name. And if it's used within a path, then it is a separator. And if you are on a local cluster or an HPC center where you are not root, then you will end up in the home directory when you log in. You can just do CD and a space and 2 dots a couple times to go to the root of the system. The 2 dots indicates the directory above you. 1 dot represents the directory you are in. We will see that again. If you run tree in the root on a supercomputing center, you probably get a large output. If you do it on your own machine, less so. This is how it would look on Tetralit. So here you have the slash and the home, and under that are people's home directories. So this would be mine, this is Joachim Hein, this is Pedro, and so on. So when you log in and you're not root, you go to the home directory. That is a good thing to always remember. It always sends you there regardless of where you were located when you last logged out. It doesn't go to the place you were in when you logged out. Always to the root directory, to your home directory. It varies what the path is. It depends on the system. So at some systems, it is just /home/ your username. At other systems, it's /home/ first letter of your username / your username. And this is some examples of how it would look for me. Of course, the username depends on whatever your username is at that system. There is a very important command that's called pwd, print working directory. If you type that, it will always show you the path to the directory you are in. And you can see it does so here. At HPC2N, it is maybe less important because there the full path is in the prompt, which is both good and bad. You can see it easily, but it also means the prompt will eventually get very, very long. At Tetralit, it only shows the nearest top level, the directory just above you, the one that you are immediately in. So you can see this is the full path, and it says exercises. And also at these centers, usually the prompt contains the name of the login node or the compute node that you are on. In this case here, I am on the Tetralit 3 login node, and it also says that this is the user that is logged in here. At HPC2N, it looks like this instead, and that is the name of the login node. If I'm on my own computer here now, you can see there the prompt is my username at the name of the computer, and then a colon, and then the prompt itself. And that will change if I go up. So let's see. There is also an easy way of going to your home directory. Again, here you have, now I have changed to this project storage directory and the directory I created. If I then were to type CD, I will go to the home directory. And you can see that by doing print working directory again. And now it shows just this path here because that is where I'm now located. So I will go back to the project storage and to the directory below it that I created. I will do that by copying this here. Copy. And then CD space and this place. And I will go down there again. There are also ways to go back to a directory that you were previously in, and we will look at that. The home directory is a special place. It has a environment variable that points to it. We will talk about environment variables later, but you can also go to the home directory or otherwise address it with CD, a space, and $home. It needs to be capital letters in this case. And here, yes, it just shows the difference in the two systems. And if I went to one of these subdirectories, I will go into my test dir and do pwd, and you can now see that is where I am. You have seen me use the command cd. The command cd is short for change directory, so it changes the directory. Just the cd and nothing else sends you to the home directory. CD, a space, and a directory changes directory to that directory. If you just give the name of the directory itself, it goes to a subdirectory with that name. You can also give a full path, as I did here. Here. And that means that you are sent to this directory here. And if you want to go back to the parent of the current directory, you do cd, 2 dots, and then you're there again. If you do cd minus, you go to the previous directory. And I'm going to show you that by doing cd, go to the home directory. And then I'm going to do cd space minus. And I'm now back in this directory I have with my exercises. And that can be very handy. So this is the structure of the exercises directory that you got when you extracted the table. There is the home directory and that you are in, or this is if you're on your own machine. If you are instead on Tetradit, for instance, then it would probably be /proj/ this long line here that you are in. But if you're in the home directory, then you could be creating it under your home directory here. So it's in exercises and whatever else you have in your directory. Then it has a number of directories under it. It has my test here, patterns and scripts. And maybe we will create more later, or maybe you do. And under my test here, there are also subdirectories. So the structure looks like this. And remember here, $home is an environment variable. It's a home directory. So that is what I write here. And again, yes, this is where it, and I forgot to change this. It should have been our MATLAB Julia NAISS, because we are now using this previous course projects instead of the one I thought I would be using. So go to where you put the exercises. Try go into the directory you created when you unpack the table. Try go into a subdirectory of it. I will do that. I will go to just see. And then there are some files onto it. And you can move back and forth the way I showed you. And you can use full paths, known as absolute paths or relative paths, to give the location. A full path is this, as I mentioned, it is the full path starting from the root and all the way down through the directory structure to the location you are in. You can sort of think of it as moving from the root of a tree up the branch, out, up the trunk, out a branch, out a smaller branch, and so on, all the way out to the directory that maybe is sitting out on nearby a leaf or something, so you go all the way out. A relative path, on the other hand, is a path relative to where you are standing. So if you are in this directory here, the exercises directory, then a relative path would be a path that was, for instance, just my test year, or it could be my test year and then test year 1. That is a relative path to test year 1 as seen from the exercises directory. Whereas what you get from PWD is the full path from the root to the directory you are in. And you can use either when you are usually addressing a place you're going to in, for instance, your job scripts. Though there are many cases where the absolute path is the safest choice when you are not sure where you will be standing when you, for instance, submit a job and run a binary. So now we know how to walk around in the files room, but we don't know how to see these files and directories that are there. Well, you have seen me use a command ls. And ls is just showing which files and directories are inside of a directory. So that is what you do when you do ls. It shows this is what is there. And you could give some flags or options to it. And you could also say, do it just for this directory. So for instance, ls/ will list the content of the root directory. This. And ls and 2 dots. Remember, 2 dots represents the directory above you. So that it tells you what is in that directory. ls and a minus would list the content of nothing right now, because on that I hadn't moved back and forth there. But the user home directory would otherwise be shown. ls star, that is the content of not just the current directory, but also the subdirectories, like this. ls star, and there are 2 subdirectories, and these are the files and directories that are inside of it. At many of the centers, the output is colored differently depending on the type. These are white ones, they are regular files when it lists it like this, and the blue ones are subdirectories, and the green ones are executable files. And in this case, it is the scripts. We will look at that later. Some commonly used flags. -D will list all the directories. -A lists everything, including hidden files and directories. That is more useful on Linux than many places because there are actually many configurations, including configuration for your how it behaves, how your own system behaves, that are hidden files. So if I do, for instance, ls -a, and then let's do that for the home directory. Then it shows a number of files here that has a dot. For instance, this one, .bashrc, which contains some configurations for how it should behave in your own system. You can do some own setups there. Whereas .config would often have configurations for many of the programs you are running. And you can see also Jupyter and MATLAB create such directories. -L lists content in long table format. That is, it lists also permissions, owners, size in bytes, modification date and time, files, and directory name. And I will do -L here. And there you can see there are 3 directories. And it also shows who owns them. So said here, everything is listed here. These are the permissions. We will look at permissions later. And if you add an extra column with H, it also represents each of the size of each of the files and directories like this, but it looks like, yes, it did here. 3.0K, so it's not very much. It's small text files. And let's add the A. Then it also shows the hidden files, and the hidden files are actually this, how to go to a directory above, and this for the directory you are in. So it's directories. You can sort by modified date in either descending order or ascending order. And that is very often useful because maybe you have a lot of files in your directory and you cannot actually right now remember what you called the file. But you could maybe remember that it's the very newest file that you created. So then you ask to have it sorted ascendingly or descendingly, because then it shows the newest file either at the top or the bottom. And that could be very useful. And capital R lists content recursively in all subdirectories. I'm now going to apply that one. See, yeah, all of the purple ones are picture files. I will go into the one called patterns, and then I will do ls. It looks like this. I will try to do ls -a. It only shows these 2 hidden files because there are no others. And then we take -l for the long form. Looks like this. And yeah, we could try and sort it like that. And then the file at the bottom is the one newest created. You can see here what date they are created. You can see the age of them, and you see this one is the newest one. If you look at the date stamp and the time stamp. If you want more flags or options, ls --help or man ls is a good command. In general, man is a way to get manual or help. You see, you will get a long file. And you escape that with a Q. Just type Q. And here is, I guess, an exercise, and you could try do this here. And I believe we are very soon where we should go to editors. No, we're still in modify. It's only time. Yeah, we have time. We have time. So let us do this exercise here, and I'm going to do it as a type along. So if you all go into exercises and go into my test dear, and I'm going to go and do that, then you can try follow along and do the same thing. So go to my test here and try to ls. And then we see the files, we see the directives. We do ls -a. We see also the hidden files. And it's -l, that's in the long format. We see the permissions, and you see the owners, and you see the group that is actually those who have access, because when you have a project storage, then everything is as default shared with everyone else who also has access to that project storage. Then comes the size, and then the date and the time, and then the name of it. So let's ls -la. Then you see it's the same, but then also it lists the the subdirectory, sorry, the parent directory and the directory itself. And then it should tell us the sizes, and it does. This is the total size of everything here. And you can see nothing very big because these files are small text files. Let's try and sort them. And here we sorted them with the newest at the bottom. Let's try to ls star and see what is below also this test directory, test tier 1 and test tier 2. And we could try going to that. And again, do ls -l to see what is there. And there are some files. And then sort them, this time sorted by the newest at the top. And it actually didn't show the time, probably because it will stop showing the time, I believe, when it's older than a certain date. I don't remember. I think that actually depends on the system you are at. But as I mentioned before, there are permissions. They are here. And we'll talk about permissions more when we come to the script session, because that is where they will be relevant. But the only thing I'll say now is that they come in 3 groups. There are one for the user, one for the group, which, for instance, is if you're in a storage project, then the group you are in are the other people in the storage project. And then also there's a section for all else. In this case, it is readable for the owner, it's writable for the owner, it's readable for the group, and it's readable for everyone else. And whether that's a good thing, that's up to you. You can change the permissions, but that is not something we will talk about now. So I will go